chord here, minimize that, put that on the left and the other one on the right. Alright, so we've got this equation here, x squared minus 5x plus 6 equals 0. Well, it wants it in vertex format. Well, do you know what vertex format is?
The x squared.
X minus h squared plus k.
Plus k. Okay.
So I need this thing to look like this. That's all I have to do, is I have to make it look like this. Well, the way I'm going to do it is by completing the square. In other words, right now the thing looks like this. I'm going to set that 6 over to the side for a moment. Where I want to complete the square is there. Do you know how to complete the square? In other words, inside the parentheses, do you know how to complete the square? Madison, you still there? Did I lose audio? Madison?
I know we did learn it, but currently I don't know. I forgot.
Hold on one moment. I lost audio for a moment, and then it came back. Okay. So you can hear me okay? We're having audio difficulties. I'm going to call you, and we'll do the audio by phone. Madison?
Yeah?
Your audio is cutting in and out on the GoToMeeting, so I'm calling you by phone, and let's do the audio by phone.
Okay.
Okay. One thing you have to do on your end is change the audio to use phone instead of computer. Otherwise, you'll end up with a nasty feedback. So go up and click on where it says audio and choose telephone. Can you hear me? Can you hear me on the phone?
Yes.
Barely. It felt like my phone audio was going in and out also. All right. Did you change the setting to use telephone? The audio setting. If you click on that audio label, there's two choices there, computer audio and phone call. Choose phone call. Can you hear me?
Yeah.
Okay. All right. So now we have audio. So what we're trying, you still there?
Yeah.
Okay. So we're trying to make this thing look like this. In other words, you always have to know your general format of an equation. That's pretty much where you start, always. You wouldn't be able to do this problem if you didn't know the general format for a vertex format. Okay? Now, to get it into this format, I got to complete the square inside the parentheses. Well, the way you complete the square is you take half of the coefficient of the x term and square it. What's half of 5?
2.5.
Well, let's call it 5 halves. Now square that, and you get 25 fourths, right? That's what I have to add, is 25/4 right there. Now, I can't just arbitrarily add a number to an equation, but I can if I add 25/4 to the right side, and I also subtract 25/4, then I haven't changed it, right?
Okay. Yeah.
Okay, so now my equation is the same as it started. The difference is that I can now write that as x minus h quantity squared. Only in our case, it's not h, it's 5/2. So that's what that becomes. Combine these two numbers. That's 6. That's minus 6 1/4, minus 1/4. There's my equation in vertex format. A is 1. Now what's the advantage of having it in vertex format is you're staring at the vertex. The vertex is 5/2, comma, negative 1/4. That's where your vertex is. And as you know, when you're working with quadratics, finding the vertex is huge. That's the most important part of a parabola, is the vertex. So you're always wanting to know where the vertex is. Well, if it's in vertex format, you're staring at it. In other words, the vertex is h, comma, k. You with me?
Okay. Yeah.
Okay. Now, the only hard part was completing the square. So I'm going to give you a different one just to make sure you can do it. How would I put this in vertex format?
It would be, let's see. So it would be y equals parentheses x.
Hold on. Don't ignore this step. Set the 16 way over here to the right and leave space to complete the square. At this point, I have not changed anything. Now complete the square inside the parentheses.
Okay, so it'd be x plus 6 over 2.
Which is 3. And now square it. What's 3 squared?
9.
So to complete the square, I got to put a 9 in there.
Okay.
Well, now I got to put a minus 9 over here. Remember, I got to do exactly the same thing, only opposite, because I'm on the same side of the equation. So now my y equals that, and it's still the same as what I started with. I have not changed it. I've just manipulated it a little bit. Now, the whole reason we complete the square is because I can now write this as x plus 3 quantity squared. Anytime you've completed the square, you're going to be able to write this term that's in the parentheses as a linear term squared. Combine your two numbers, you get plus 7. You got it in vertex format. Where's the vertex?
Negative 3, 7.
Correct.
Wait.
Negative 3,
Yeah.
comma 7. Correct. Because it's x minus h. So in this case, h must be minus 3. So completing the square is actually fairly easy. Let me make one additional change to this problem just to illustrate a slightly higher degree of difficulty of completing the square. And this time I'm going to put a 2 there and an 8 there. All right. Now, if I do my first step, it's to put both variables in the middle inside the parentheses, leaving space to complete the square. Okay, you with me? You cannot complete the square until the coefficient of x squared is 1. So the very first thing I have to do is factor out a 2. Make this thing read like this. Still leave room because I still have to complete the square. But the key is, fundamentally, I have not changed the equation. And that's what you want to not do, is change the equation. You always want it to be the same. Now complete the square inside here. And you're always adding a number to complete the square. Because notice that even if that were a negative number, when I take half of it and square it, it turns it positive. So I'm always dealing with a positive number over here. What is it?
Okay. It would be x squared.
Hold on. It's not x. It's a number. There's no more x.
Oh, in the blank space. Okay, so
you take the coefficient of the x term, which is 4. So 4 is the number you're dealing with. Now what do you do to it?
Square it.
Cut it in half and take the square of it, not the square root.
Okay.
Cut it in half, it becomes 2. Square 2, and 4 goes there. Now, when I wrote that 4 in, how much did I add to the right side of the equation?
Add to it? What do you subtract?
How much did I increase it by? In other words, what's the difference between not having a 4 there and putting a 4 in there? In other words, how much do I have to subtract from 16 to counterbalance that 4 I just put in there?
Subtract 4.
8. Notice that when I put the 4 in there, that 4 is being multiplied by this leading 2 that I factored out. So I really added 8. So I now have to subtract 8. Now it's the same. In other words, now this equation is the same as that, what we started with. Because I completed the square, I can write this as how?
X squared.
No, it becomes a linear term. X plus 2 squared. In other words, whatever half of your coefficient was, that's what goes here.
Okay, and then plus 8.
Plus 8, exactly. And notice now I have it not only in vertex format, but now I know A, H, and K. A is 2, H is minus 2, and K is plus 8. But you can see why this was tougher. When you've got to factor out a number, then when you complete the square, you have to make sure you counterbalance it by whatever you completed the square with times the number you factored out. In other words, I don't subtract 4, I subtract 8 from the same side of the equation. Now, sometimes you're going to be completing the square where you're completing it on the other side of the equation, and you've got to be a little careful. In other words, if I add 8 to this side of the equation, I would have to add 8 to the other. But since I'm doing everything on the right side of the equation, when I add 8, I got to subtract 8 to the same side of the equation. All right, let's see what else they got here. Okay. So this equation is y equals minus 6x squared minus 2x plus 7. Find the vertex by completing the square, and I'm going to find the vertex by putting it into vertex format. Remember what vertex format is? This. So I've got to make my function look kind of like this. I've got to solve for A, for H, and for K. And I'm going to do it by completing the square. First thing I'm going to do is separate the terms. Anything that has x in it, I'm going to put together. I'm going to put parentheses around it, and I'm going to leave room to complete the square. Like that. In other words, I haven't done anything to it yet, other than just put parentheses around two of the terms. Now, what do I have to do before I can complete the square?
Take out 6.
Minus 6.
6x squared. Minus 6.
Minus 6. So I'm going to factor it out just from this part of the expression. It leaves behind this, and notice that it leaves behind that. Same thing or not?
Yeah, same thing.
That's what you always want to do. At every single step of the way, make sure that you're looking at the same exact equation that the previous line showed. It's just written differently. But now I can complete the square because I've got a 1 in front of my x squared term. So how do I complete the square?
So the half of 1/3, right?
What's half of 1/3?
1/6.
Now square that. It's not half of the coefficient, it's half of the coefficient squared. So 1/6. 1/6 is half the coefficient, but now you got to square 1/6. What do you get?
Would it be...
What's 1/6 times 1/6?
So 1/36.
Yep. Now, I just wrote a brand new number into my formula. I got to counterbalance it by doing something over here. And the way I can figure it out is, what did I do to the equation when I wrote 1/36? How much did I add or subtract to the right side of my equation?
So you subtract 1/36 on the right side.
Not 1. It's being multiplied by that minus 6.
Oh,
the moment I wrote that in there, I'm subtracting 6/36 from the right side of the equation. Subtracting. So I have to add 6/36. You see why?
Okay. Yeah.
Make sure you understand that precisely. In other words, it's not 1/36 that I have to balance out. It's this number times that number, which is minus 6/36. So to balance it out, I have to do the opposite. I got to add 6/36. And I'm purposefully not simplifying that yet. I understand that 6/36 is 1/6. But the key ingredient here, oh geez, sorry. The key is now how to write this. Remember, I got to write it so that it looks kind of like that. X minus h quantity squared. What's my h going to be? And is it plus or minus here?
It would be minus.
No. It's got to be plus. There's nothing but pluses in here. That's a plus and that's a plus. And now, what was half of a third?
1/6.
if you square x plus 1/6, you'll get this. You'll get x squared plus 1/3 x plus 1 over 36. So the key understanding here is the reason you complete the square is so that you can write it as a linear term squared. X plus 1/6 is a linear term. And then it has to be squared. And I still have my minus 6 out there. Combine those two numbers and I get 7 1/6. So there's my answer. I've got it now in vertex format. Tell me where the vertex is.
The vertex would be negative, no. No, you don't. So it would be negative 1/6.
The vertex is h comma k. H comma k. Well, what is h?
Just 1/6.
Right. That's where the x coordinate, only it's minus, my mistake. It is minus because it needs to be x minus h, and so h must be minus 1/6. But k is 7 1/6. Now, can you tell whether we're looking at a parabola that goes like this, or are we looking at a parabola that goes like that? Opening up or opening down?
I would imagine opening up.
If this A is positive, it opens up. If it's negative, it opens down. So here's the one we're looking at. And their final question was not just where is the vertex, but is it a maximum or is it a minimum? At that point there, a maximum of the function or a minimum of the function?
Minimum?
Maximum. It's the highest point, right?
Okay, yeah.
If I drew a parabola like this, well, that vertex is a maximum. The function never gets higher than that because the parabola opens down. If the parabola were to open up like this, well, now the vertex is down there, but I can plainly see that it's a minimum. And so whether it's a minimum or a maximum has everything to do with that sign right there that is in front of the 6.
Okay.
That sign is negative, it opens down, making it a maximum. That sign is a positive, it opens up, making it a minimum. All right, let's see. I hear my bell going off. Why don't we stop there? And I'll make a note that we made through 63, and we'll pick up with 64, another completing the square, next time.
Okay.
Okay, all right, Madison, have a good week. Let's see, you're on spring break next week also, right?
Mm-hmm. Yeah.
I will let you, since you schedule on your own, I don't think you have anything scheduled for next week. Let me just look real quick here. So there's nothing I need to do for you. Yeah, I just talked to her and she said cancel hers for next week. All right, so I will probably talk to you in a couple of weeks.
Okay, sounds good.
Have a good spring break.
Thank you, bye.
Bye-bye.